So in this video we're going to define the natural log function and identify what the derivative of the natural log is. So the natural log function is a function you would have seen in pre-calculus course. In pre-calculus they would have defined the natural log function in terms of exponents base e. In calculus we define the natural log function as the signed area under the curve of 1 over t. So we take the function f of t equals 1 over t and we look at it on the closed interval from 1 to x, and we calculate the signed area on that closed interval from 1 to x. When we were developing definite integrals, because we have a definite integral here, we know that we define them in terms of creating rectangles whose bases had width delta t, and we calculated delta t by taking the right endpoint of the closed interval minus the left endpoint of the closed interval and then dividing it by the number of rectangles that we had. So we took a limit as n went to infinity of delta t, which is defined as x minus 1 over n, and then we took the sum from I equal 1 to n rectangles, and then we added up the function. So we're going from 1, it was the function evaluated at 1 plus I times the delta t that you were working with. And the key is that you've got this multiplier out in front of that summation. So if x happens to be greater than 1, what you can see is you're going to have a positive number here. This number will be positive. And so this area calculation, the area from 1 to x, will give you a positive area. But if x is less than 1, so here's 1, if we have x less than 1, then the difference x minus 1 is going to be negative. So if x is less than 1, you get the area under the curve, but it's going to have a negative sign on it. So we get a signed area. So the thing that comes right from this definition of the logarithm, so we have this definition for the logarithm, the thing that comes directly from it using the second fundamental theorem of calculus is that we know the derivative of the logarithm is going to be, if we take ln of x, and then we take dx of ln of x, we know we're doing dx of the integral from 1 to x of 1 over t dt. We know from the second fundamental theorem of calculus that this derivative is just 1 over x. In other words, we take that variable upper bound of integration and we replace the t in the integral with the x. And then we know from the work that we did with the second fundamental theorem of calculus that if we happen to have a function of x up here instead, that we're going to get the derivative as 1 over the function, and then by the chain rule we have to multiply by u prime over x. So in general then, the derivative with respect to x of the natural log of a function of x is always going to be the derivative of the function. You wind up with the derivative of the function over the function itself, and this again is just directly from the second fundamental theorem of calculus. In the subsequent videos, the next 3 videos, will show examples of finding derivatives of natural log functions or functions involving the natural logarithm.